Okay, we're working on number 11 here. I hope you took a minute to read the problem before you started in on the video. First of all, the most important thing, the main thing that I have to emphasize on any word problem is understanding your variables and interpreting your variables and writing let statements. Okay, so we're going to do some complicated word problems later in the course. If you can get the hang of this, using your variables and understanding what they mean, if you can get the hang of it on these easier problems, you're going to be much better off down the road. So first of all, what's t, right? We have two variables. We have t, we have f of t. All right, t, we're told right in the directions. Let t equal temperature. Should probably specify in Celsius. I'm being lazy with what I'm typing. Now, reading the problem then, what is the output then? We input the temperature. What is it that we're outputting? What does f of t represent? And remember, f of t is our y. And I did put the little hint in here. You know, when we go to the calculator, we're going to have to put an x for t, right? So that's our input, right? And then f of t or y is our output. And what is it that we're outputting? We are outputting the number of larvae in the sample. Should sort of remind you of that cricket problem we did the other day, right? Where the crickets couldn't chirp if it were too hot or too cold. Okay, so the larvae can only live in a certain temperature. Now, I know this is a handout on linear functions. However, if I were to distribute this, notice I would get right here 2.5 t squared, right? As soon as I see t squared, I've got a quadratic. I don't have a linear function. This is quadratic. Number 2 is the easy part of this problem. How many larvae are present? So the number of larvae is the output, the f of t, right? This is the output when the input is 20, right? So when t is 20. So like I said, when you have to plug in, you know, and I joke with students that they randomly plug in because you do have a 50-50 chance. They randomly plug in and hope for the best. But that's just where you look at your let statements, right? When I want to know how many larvae, I look here and say, oh, that's the y value. That's the output, right? Temperature is the input. All right, so now we're going to look at t-intercepts, which I did say up in the hint. These are the x-intercepts. All right, and so I should know that is when y is 0. So I have said this dozens of times already in this course. I hope it's stuck in your brain by now. X-intercepts, y are 0, right? What do they represent physically, right? Well, first of all, let's find them. Let's find them. So we've got this quadratic. It's already been factored for us. To set f of t equal to 0 and solve, so I'm putting a 0 in here, I have to take each factor and set it equal to 0. Okay, so that's how I solve my quadratics. We know how to do that. We've been doing that many times in high school. All right, so we solve by setting each factor equal to 0, and then t is either 0 or t is 60. Okay, so then what does this mean, right? And this is where, again, look at our let statement. What does it mean for y to be 0? And let's draw the picture. Okay, these are our x-intercepts, right? They touch the line, they touch the x-axis, right? Y is 0. Okay, well, what does it mean for y to be 0? That would mean no larvae in the sample. Okay, so how do we interpret that? And that's where we would say something like, we could talk about the domain then being 0 to 60, or simply write, you know, larvae can only survive in temps between 0 and 60 degrees. Okay, so this answer should go up here, but I kind of ran out of room. All right, so what's the maximum, put it up here. What's the maximum number of larvae present in the sample? Okay, and I told you to graph it. So I will stop share here, and I've already programmed this into my calculator, which I'm going to share. And so I type it into here, 2.5x times 60 minus x. Okay, so do that along with me. Then I go to graph and say, what the heck is that? My calculator's broken, right? And sometimes I've had students come up during a test and say, I don't know what's going on, my calculator's broken. Why does it look like this? Well, I have to think about, you know, we're set on -10 to +10 as our range and domain. We have to think about the window, right? So go to window. No, I don't want table set. I want window. There we go. So x is only going from 0 to 60. And then I want to show you this wonderful feature on your calculator called Zoom Fit. If I put in the window, my calculator, if I go to Zoom Fit, which is down here, it's 0. If I go to Zoom Fit, it will automatically adjust the Y value for me. All right, and then I'm asked to find the maximum. Okay, so here I would go to second calculate, right? Find the maximum. And let's see, I want to be to the left of it, so make sure I'm to the left. Make sure I'm to the right. Hit enter. And then I have to interpret, okay? So this would round off to 30, and we know because of the symmetry of this parabola, we are finding our maximum right in the middle. But again, I have to look at my let statements, right? What does X stand for? Is that how many larvae there are, right? But I look back at my let statements and I see, no, that's not how many larvae there are. That is temperature, right? X stands for temperature. So let me share screen with the one with the answer key, right? X stands for temperature and Y stands for the number of larvae. And that's how we get our answer there. So again, if you can get a handle on understanding variables, using let statements, using your calculator to its maximum benefit, that will greatly enhance your success later in the course. So thank you for watching.